this video, I'm going to show you how we use design thinking in Physics Olympics. Design thinking is a process emerging from a constructivist perspective of fostering problem-solving and process skills, creativity, and innovation. Students are highly engaged in collaborative activities where they can interact with other students, take ownership of their own learning, and apply what they have learned to provide solutions and present their findings. In Physics Olympics, students were grouped in a multi-level scale and presented with engaging and thought-provoking challenges that need resolution. Students first understood and defined what the problem was, then generated a wide range of creative solutions quickly. They modeled and built prototypes of their best ideas, thus creating concrete devices out from local materials available like newspapers, empty PET bottles, strings, plastic straws, and woods. After adopting hands-on approach in prototyping, they evaluated and refined their prototype, tested and used their finished product, and finally, they showcased and pitched their project to the board of judges and learning audience, synthesizing the physics concepts and principles underlying the presented task to the guide of open-ended assessments. Findings revealed that the utilization of the design thinking process in the Physics Olympics helped develop student skills and abilities, both personal and interpersonal skills. Just-in-time acquisition of knowledge and conceptual formation and application, and active learning through collaboration. Suffice it to say that design thinking in Physics Olympics positively enhance students' conceptual understanding and motivation towards the physics concepts and its application. I hope you enjoyed this video. Thank you for watching.
Today, I am going to put you in the shoes of a public school teacher. Your task is to improve your students' conceptual understanding on electric potential. Seems easy, right? But you only have 4 hours to do that. The topic is too long and abstract in nature, so you need to properly plan your lesson. You want your students to perform experiments, but it will take so much time, and the materials in the science lab are unavailable. You also want to give lots of sample problems, but your students seems to focus on memorization rather than on understanding the concept behind the problem. So these are just some of the common problems a high school physics teacher is facing in planning for a good lesson. And these are the same problems I want to address in my study. The aim of my research is to investigate the effect of mobile technology-enabled active learning approach on students' conceptual understanding in electricity and magnetism. The approach involves the use of simulations in lesson discussion, peer teaching, and mobile simulated experiments. To achieve this, I developed a learning module which was validated by 3 experienced physics teachers. The second stage is the administration of the module and the instruments in a public high school. The last stage is the analysis of the results. Data from the worksheets showed significant improvement in the level of conceptual understanding of the students. This was supported by the result of the classroom observation and students' self-reported questionnaire. The students also perceived the use of simulations helpful in visualizing the lesson. For the students, peer instruction helped them to self-assess their understanding, allowing them to understand the concept behind the problem. They also described mobile simulated experiment as effective and time and cost friendly. Extensive implementation of the MPhil approach is possible, especially now that the Department of Education proposed the new normal in education due to the COVID-19 pandemic. The MPhil approach can be used solely and incorporated to other approaches to allow students to learn at their own pace under a guided module in the comfort of their home.
Greetings, everyone. Let me present to you my action research entitled Students Improve Understanding in Nuclear Physics in a Flipped Classroom, co-authored by Dr. Voltaire Mistades. The study aimed at improving physics instruction through flipped classroom approach. In particular, the study sought to answer the following. What is the effect of flipped classroom approach on grade 10 students' conceptual understanding of nuclear physics? And what are the students' perceptions on the use of flipped classroom in the context of physics instruction? Here comes the intervention to improve the teaching of physics, the flipped classroom. Flipped learning engages students to learn the fundamental concepts at home, then come to class for enriching activities. This research applied the PDSA cyclic model. It also employed the quasi-experimental approach, and both quantitative and qualitative methods were used to examine the effect of flipped classroom. The primary source of data to determine the effectiveness of the intervention is through pre-test and post-test. The learner's results on average improved with a gain of 12.6 in the mean scores for the post-test. This difference in pre and post-test result is statistically significant. Results revealed that the intervention of flipping the classroom improved the teaching of physics. Flipped classroom was also perceived positively by the students. As a result of improved instruction, there is an increase in the conceptual understanding of the students. They also like their experiences in a flipped classroom format. Further, flipped classroom can address the problem of multiple class suspensions. That ends my presentation. Thank you.
This action research is entitled Enhancing Understanding and Engagement in Linear Motion Using 7R-Based Module. This study aimed to improve physics instruction by determining the effectiveness of 7R-based module, otherwise known as MVOC, with simulation in addressing problems such as difficulty in understanding subject matters, lack of materials, student engagement, and time constraints. This action method employed the mixed method approach wherein both qualitative and quantitative research data were used. The results of this study revealed that there is a significant difference on students' understanding in linear motion before and after the implementation. Moreover, the scores on activity and problem sets have a very good to excellent rating, which signifies an increase on the level of students' conceptual understanding. There also an increase in overall student engagement and significant difference on the dimension of emotion and participation or interaction before and after the implementation. These findings were supported by gathered qualitative data. Positive views were elicited from the students since the module it helped them understand the lecture more and study in advance. However, it is suggested to aid MVOC with simulations, games, or videos to enhance student engagement. The results of the study may substantiate that using MVOC or the 7R-based module will lead to better physics content understanding and higher engagement.
Learning physics requires the understanding of both concepts and solving problems. Unfortunately, one of the most usual scenarios that a physics teacher encounters are students having difficulty with regards to solving physics problems. With this, an effective strategy should be used in order to improve the physics problem-solving skills of the students, and in this study, that strategy is the use of metacognition. Metacognition is defined as thinking about thinking or the ability of the students to determine the best way he or she can learn. This study explored the effects of using various metacognitive strategies in teaching physics problem solving in grade 12 students such as the following. It specifically aims to answer the following questions. It is also anchored to the Plan, Study, Act or PDSA cyclic model. Before the implementation of the study, the students were given a pretest exam about the 1 and 2-dimensional motions, which were taught for 2 weeks. It uses various metacognitive strategies such as exit ticket, metacognitive modeling, metacognitive note-taking, think per square, logical problem-solving model. and exam wrapper. The study revealed that before the intervention, all the students were described to have a below beginning level in physics problem-solving skills. The identified primary difficulty was analyzing the problem. Additionally, Wilcoxon's sign rank test showed that the performance of the students before and after the intervention was significantly different. Lastly, a significant relationship was found using Spearman's rank order correlation, which indicated a significant relationship between metacognitive awareness and physics problem-solving performance. Thus, the researcher concluded that the various metacognitive strategies used in this study increased the problem-solving skills of the students and is recommended for physics teachers to incorporate in teaching.
Hoy, kamusta kayo mga kabaryo? Isa na namang kabanata ng Barrio Agham.
Hoy, hindi Barrio Agham ngayon. Ano ka ba? SPP presentation.
SPP presentation ba?
Oo.
Kamusta? SPP! Ako nga pala si Ninya.
Ako naman si Vida.
Ako naman si Marty.
Ako si Nene at kami ay mga
Pueblo Science
Volunteers.
Ang Pueblo Science Philippines ay naglalayon na matulungan ng mga kabataan sa pag-aaral ng STEM.
Ito ay sa pamamagitan ng mga DIY na experiment na tunay na nakakamangha at nakakawaw as in wow na wow.
Kaya naman, gumawa ang Pueblo Science Philippines na isang segment na Barrio Agham upang maturuan ng kabataan ng mga experiment ngayong panahon ng pandemya.
Handa na ba kayo matunghayan ng isang eksperimento na ginawa namin sa Barrio Agham?
Ang kailangan lang natin ay inyong mga kamay at mga bibig. Okay, hipan ang inyong mga kamay ng may malaking pagbukas sa bibig. Mainit, di ba? Ngayon naman, hipan ang inyong kamay ng pasipol. Anong naramdaman nyo? Mas malamig, no? Bakit kaya? Ninya?
Isang bagay na kailangan nating alalahanin sa experiment na to ay mas malamig ang hangin kapag mas nag-expand o lumalawak ito. Sa case natin kanina, lumiliit ang butas ng ating bibig, ngunit ang resulta nito ay lumalawak ang expansion ng ating hangin. Kaya naman, lumalamig ang hangin na ating nararamdaman sa ating mga kalat.
Wow! Science!
Isa lamang yan sa matutunghayan at papapanood nyo sa Barrio Agham sa aming Facebook platform.
Meron din kaming TikTok videos.
Gusto niyo bang sumali sa amin? Tara at maging volunteer. I-contact niyo lamang kami sa aming Facebook page. At syempre, huwag niyo kalimutang i-like ang aming Facebook page.
As time passed, people from ancient time to present are continuously searching for ways to make life better. Fishing is one of the livelihoods of the people in the coastal areas. It is one of their primary sources of income as well as food for their families. No matter what the weather condition is, fisher folks still go to the sea to make a living. That's why I pursue context-based learning and physics for fishing communities. This study focused on the indigenous fishing practices in the fishing community that were used as context in teaching physics. It involved the documentation and description of the indigenous fishing practices in Alimsog, Santo Domingo, Albay, the identification of physics principles applied in the fishing practices, as well as the knowledge gaps, the development of instructional materials and lessons using the context of fishing practices that were used in Alimsog Integrated School and San Antonio National High School. Under the methodology, this research embraces three phases. First one is community immersion, where the researcher immersed in different fishing activities for 2 months, development and validation, implementation of the lessons, that leads to 4 results. Number 1 result is that the indigenous fishing practices of fishermen are pag-ikot, pagpana, pagbanwid. Second result, context-based physics lessons on mass, loss of motion, buoyancy, pressure, visible light, reflection of light, and reflection of light and sound. Third one, the context-based lessons using indigenous fishing practices were found effective. And here are some examples of the pictures during the symposium, tree planting, coastal cleanup. And the last result is that knowledge of physics concepts and principles can improve the fishermen's practices in using gears and other techniques to improve efficiency, conserve energy, and promote safety during fishing activities. Just watch more videos in my YouTube channel, I'll Be Bestman. Thank you.